Welcome to the next page, which talks about the definition of a limit. This is also known as the Epsilon-Delta definition. And basically what this says is if you have a graph, and let's say you have an x-coordinate here, c, and we find the limit of c to be L right here. All right, so notice we have, there's L, there's C. All right, what this is saying is that if you change the horizontal distance, and it doesn't matter if you go this way or this way, we'll call the horizontal distance delta. This would be, it could be either direction. So this would be like C minus delta. And C plus delta here. My deltas aren't the greatest. All right, so this is basically the horizontal distance that you change. That in that same range, the vertical distance, which we will call epsilon, will also change and basically change the same amount, so that the change in what's called the horizontal distance that you change from the x-coordinate, then there exists an epsilon that will also represent the vertical distance. So let's do some examples here. So the first thing, in order to prove that the epsilon delta definition works for the limit, is the first thing you need to do is find the limit. So substitute in the -2, and you get -3. So now that's step one. Step two, it said to write the two inequalities stated in the definition. So first of all, the horizontal distance is between 0 and delta. It looks like an 8, but it's a delta. This also, the vertical distance is going to be less than epsilon. All right, so then we're going to substitute the appropriate values for C, the f of x, and the L. So basically here, we have x minus -2, so it's x plus 2, is less than delta. And then we also have the function, so 4x plus 5, minus the limit, which is minus a negative, so it's plus 3, is less than epsilon. So now you want to make the absolute values appear to be identical. So that means basically we'd have to change this in order to be x plus 2. So what we have to do is say, okay, well, if I add 5 plus 3, I get 4x plus 8. And then I can factor out the 4. And then notice the absolute value of 4 is 4, so I can pull that out. So I get 4 times the absolute value of x plus 2 is less than epsilon. And then I can divide by 4. So the absolute value of x plus 2 is less than epsilon divided by 4. So notice they're the same. So now we have to state the value, what delta must be. So delta must be equal to epsilon divided by 4. So in order for the limit to hold up, delta is equal to epsilon over 4. And that is your final answer. All right, so let's try again here. So here we have the limit as x approaches 16 of the square root of x. And the first thing, if we take the square root of 16, we get 4. So that's our limit. So writing our inequalities. And then the second one is the vertical distance is less than epsilon. All right, so then substituting in, so the absolute value of x minus 16 is less than delta. And then here, the function is the square root of x, minus the limit, which is 4, is less than epsilon. All right, so the hard part here is we need to get these to be identical, right? We need to get this one to be x minus 16. So in order to do that, in order to get the square root of x minus 4 to be x minus 16, we need to multiply by the conjugate. So the conjugate here is the square root of x plus 4. But I mean, we have to do that to both sides. So that we get the same inequality. So here, when we FOIL, this is the absolute value of x minus 16 less than epsilon times the absolute value of x plus 4. Now, we need to figure out the absolute value of x plus 4, what that can equal. All right, in this function here, remember we're taking the limit as x approaches 16 and the limit is equal to 4. Right, so the x value that we put in, the ones that are next to 16 as perfect squares are 9 and 25. So basically, when we're talking about the square root of x, in this case, our limit is between 9 and 25. Those are the numbers that we're putting in to get close to the limit of 4. So now, if we take the square root of that, that means that the numbers are between 3 and 5. And then if we add 4, so 3 plus 4, and the square root of x plus 4, and 5 plus 4, that means the square root of x plus 4 must be between 7 and 9. And since we're talking about being less than, we're trying to minimize, so we're going to choose 7 because of the fact we want to minimize the distance. So we want to minimize the distance. So the absolute value of x minus 16 is less than 7 times epsilon. All right, so now we've got them to be the same, and that means that we're going to let delta equal 7 times epsilon. Let's try another one, see how it goes. So remember, first thing you do is you find the limit. So 3 squared plus 3, that is 12. So then what we're saying is that the horizontal distance has to be in a range between 0 and delta. And then the vertical distance from the limit has to be less than a number epsilon. All right, so our c value is 3, so the absolute value of x minus 3, the horizontal distance. has to be between 0 and delta, and the vertical distance away from the limit, which is x plus 3 minus 12, the absolute value, is less than epsilon. So if we look here, this is x squared minus 9, which is less than epsilon, which factors to x plus 3 times x minus 3, absolute value. And remember, we're trying to get x minus 3 isolated here, so that means we have to divide by the absolute value of x plus 3. So notice you get the absolute value of x minus 3 is less than epsilon over the absolute value of x plus 3. Now we're going to try to minimize what the absolute value of x plus 3 can be. So we'll do the same thing we did, is choose x. So that now, remember, we chose 3. 3 is what x is going toward, so the two numbers to the left and right are 2 and 4. So basically, those are the two integers that are on one side or the other of 3. And if you add 3 to both sides, because that's what we want to get, 2 plus 3 is less than x plus 3, which is less than 4 plus 3. So 5 is less than x plus 3, which is less than 7. So that means the absolute value of x plus 3 has to be between 5 and 7. And if you want to minimize, because it's a fraction, the higher the number you put in the denominator, the lower the fraction is. So we're going to choose 7 because that's going to minimize the value. So the absolute value of x plus 3 is equal to 7. So that means that we're going to so that means the absolute value of x minus 3 is less than epsilon over 7. So that means that delta has to equal epsilon over 7. All right, last one here. Similar situation. So we put in the negative 4. So we get 16 plus 16 minus 16, which is 0. So that's the limit. So that's our L. So now the vertical distance, x minus c, is less than delta. And the vertical distance, the horizontal distance is less than delta. The vertical distance is less than epsilon. So now negative 4, so that means it's the absolute value of x plus 4. And then f of x is x squared plus 4x, but the limit is 0. So that means we have the absolute value of x squared plus 4x is less than epsilon. Factor the x. So notice here we're going to have to divide by the absolute value of x. So the absolute value of x plus 4 is less than epsilon over the absolute value of x. So now, remember, the numbers that we put in, or the number that we put in for c was negative 4. So the values to the right and to the left of that means it's negative 5 and negative 3. That's what negative 4 is between. And in this function, and if we take the absolute value, notice we get 5 and 3 is what it's between, 3 and 5. Now, remember, we want to minimize the value here. So that means that in order to make it the smallest possible, we'd have to choose 5. So the absolute value of x plus 4 is less than epsilon over 5. So that's the smallest distance that you can get. So that means that we have to let delta equal epsilon over 5. All right. So I hope you enjoyed the video, and if you have any questions about the Epsilon-Delta or anything we did previously, let me know. Have a good evening.